Let's continue on with the problem of spam detection. In the last class, we saw the naive Bayes classifier, which is one way to approach the problem of spam detection. There are other machine learning based approaches as well that you can use to solve spam detection or any other classification problem. We'll look at a couple more examples such as the k-nearest neighbors and the support vector machines methods. Let's get into it and see what they are. Let's think for a moment about shapes before we do that. These are a few shapes: a line, a square, a cube. Now these are all different shapes, but what is common between them? What is the thing that describes a shape? All shapes are basically sets of points. That is what really is a shape. It's a set of points. Let's look at a few commonly heard statements and see what they really mean. A line is a unidimensional shape. A square is a two-dimensional shape. A cube is a three-dimensional shape. You might have heard this before and you might have said it as well, but do you know what it really means? A line is a one-dimensional shape. A line can be represented by a set of points which all can be described using one number. That one number is the distance from the origin. A square is a two-dimensional shape. A square, any point in a square, can be described using 2 points, x and y, which are the coordinates of those points. This is the distance from the x and y axis. A cube is a three-dimensional shape. It is described, or any point in a cube is described by 3 points, which are the x, y, z coordinates. To summarize, the number of coordinates required to describe a point in a shape are basically the number of dimensions of a shape. So a point in an n-dimensional space will need n coordinates to describe it. Now, in reality, you may find it hard to visualize 4 or more coordinate spaces, anything which is a higher dimension than a cube. But there's no magic about them. Just think of each point as a tuple of n numbers. Just like a three-dimensional space needs 3 coordinates or a tuple of 3 numbers to represent it. So we've talked about points in n-dimensional space. What about shapes in n-dimensional space? A two-dimensional space is represented by a rectangle. A three-dimensional space is represented by a cube. So what is the shape in n-dimensional space? An n-dimensional space is represented by an n-dimensional hypercube. Notice the word hypercube, somewhat inspired by the word cube. Don't get intimidated by the word hypercube. It's nothing fancy. It just means that each point in this shape can be represented by a tuple of n numbers. That's all it means. Now, with this in mind, let's get back to our spam detection problem. So, why did we talk about shapes and spaces and n-dimensional hypercubes? The reason is that we'll represent each email as a point in an n-dimensional hypercube. So any email message can be represented as a point in a hypercube. This was our objective behind talking about all of this. But how will we do it? Remember that we had already mentioned that a problem instance consists of a feature vector. These are the attributes that describe that problem instance. The list of attributes that we care about is called the feature vector. Now let's say we have a list that represents the entire universe of words that can appear in an email. W1, W2 to Wn is that list. For simplicity's sake, let's take a very small number of n and let's just say that this is the entire list of words that can appear in an email. So no other words can appear in any email. Then any message or email would only contain a subset of the words in the above list. Let's take a few examples. Let's say these are the three messages. Hello, this is a test is the first message. How are you is the second message. Hello all, goodbye is the third message. Each of these messages can be represented as a tuple of ones and zeros. I have represented the first message here. Basically, each element in this tuple represents whether the word I is present in this email or not. So 1 means the presence of a word, 0 is the absence of a word. Since this email contains the words hello, this is a test, the elements corresponding to hello, this, is, a and test, the 5 of these elements are marked as 1 and the rest are marked as 0. This is how you can represent any email message as a tuple of ones and zeros. Let's see a couple of other examples. As you can see, we only use 1 when the word appears in the email and 0 when the word doesn't appear in the email. Now all these tuples are points in an n-dimensional hypercube. The ones and zeros or the elements of these tuples represent the coordinates of that point in an n-dimensional hypercube. So using this simple method, we've been able to represent an email message, which is a text document, as a point in some n-dimensional space. Now that we've done that, what do we do next? This is where some cool machine learning algorithms come in. First thing we'll do is we'll take the email we want to classify as well as all the emails for which we already have labels, emails which are marked as spam and ham, and we'll represent them in the same way as points in a hypercube. The email we want to classify is called the problem instance, if you remember, and the emails that we already have information about are called the training data. We had already learned about this. The distance is a measure which describes the similarity of these points. The closer they are, the more similar they are. The farther apart they are, the more dissimilar they are. Now, there are a bunch of different ways to calculate distances between points in an n-dimensional space. The super simple one, which you might know about, is the Euclidean distance. Now, the Euclidean distance formula is very simple, and in 2 or 3 dimensional space, it just represents the physical distance between 2 points. So if you have 2 points x1, y1 and x2, y2, you would just take the differences of the corresponding elements. So x2 minus x1 and y2 minus y1. The square root of the sum of squares of these two numbers is the Euclidean distance. In 2 or 3 dimensional space, as I said, this represents the physical distance between points. In an n-dimensional space that we would find it hard to visualize, it is just an extension of the formula. So you would just take x2 minus x1, y2 minus y1, z2 minus z1 and so on, and apply the same formula. Now that we know how to calculate the distance between points, we can find which are the points which are nearest to the point that we care about. So we'll find the k nearest neighbors. K is a number that you'll have to decide appropriately. Once you find the k nearest neighbors of our problem instance email, If more than some threshold of them are spam, we'll mark it as spam as well. So we'll take a majority vote of the nearest neighbors. Here's a visual representation of the k nearest neighbors algorithm. We have represented all our points in space. This is called the feature space. The blue points are spam and the red points are ham. We could do this in a bunch of different ways. One simple, easy to understand way we already described. The green point is the problem instance or the new email that has come in. Now, inside the circle are the k nearest neighbors of that point. Since most of these k nearest neighbors are blue or spam, we'll call our problem instance also a spam email. This is simply the k nearest neighbors algorithm. In order to make it easy to understand, we've made the setup above slightly simpler than reality, but not by all that much. What would change in real life? The feature vector will almost never contain a tuple of 0, 1 numbers. Instead, a smart hashed subset of the email would be used. This would be to reduce the complexity of the computation that is involved. Similarly, the distance would not be a straight Euclidean distance, but some formula that is found to work well in training. Now, like the naive Bayes classifier, the k nearest neighbors is also a form of supervised learning because it clearly starts with a set of data which is already labeled. Now, as you can see, there are some differences between the k nearest neighbors classification and the naive Bayes classifier. The k nearest neighbors makes no assumptions about the probability distributions of the feature vectors. So, in the naive Bayes classifier, we assume that the features are independent. The k nearest neighbors makes no such assumption. For this reason, it is known as a non-parametric classifier. Non-parametric classifiers basically make no assumptions about the probability distributions of the features that they are using. Naive Bayes classifier does indeed make assumptions about the probability distribution. As we mentioned, it assumes that the probability distributions are independent. We didn't go into much detail about this in the previous class, but we will in the future. Anyway, naive Bayes classifier is said to be a probabilistic classifier. Very briefly, we'll touch upon another classification technique which also represents all the problem instances as points in an n-dimensional hypercube. This method is called as support vector machines. Support vector machines are non-probabilistic classifiers. So they also do not make assumptions about the probability distributions, similar to how the k nearest neighbors does it. They are also an example of supervised learning. So support vector machines are supervised learning models that are used to build non-probabilistic classifiers. Now, unlike the k nearest neighbors method, this one only works if there are two labels. For example, it will work for spam detection because we only need to classify as spam or not spam. Thus, SVMs are used to build binary classifiers. This was a visual representation of k nearest neighbors. As you can see, since the problem instance has all its nearest neighbors as spam, it was marked as spam 2. Now, let's see what the difference is with support vector machines. Like the k nearest neighbors, support vector machines also represent the problem instances as points in an n-dimensional hypercube. So they start off by taking an email and representing it as a tuple of n numbers. That step is the same. But it basically tries to find a separating boundary between the two clusters, spam and ham. It finds this boundary, which is called a hyperplane. This hyperplane will neatly separate the two groups of points, spam and ham. Now, a hyperplane is nothing complex. In a two-dimensional space, a line is a hyperplane. In a three-dimensional space, a plane is a hyperplane. So, in an n-dimensional space, any n-1 dimensional shape is a hyperplane. This hyperplane then acts as something known as the decision boundary. Any point which falls on one side of the hyperplane will be assigned to that side or the category which is on that side. So any point on one side is ham and on the other side is called spam. This is the basic idea behind using support vector machines.